So terminal velocity is basically, it means that things that are usually falling but well moving. Let's say that we have any sort of object that has some sort of force pushing it one direction. It's going to, if it's moving through a fluid, and I'll explain what a fluid is in a moment. But if it's moving through a fluid, in fact, let's sum this up in words first. So if an object is, in fact, I'm going to pause the video. So let's just, yeah. So if an object is moving through a fluid, liquid, or so a fluid is anything that can flow, not just a liquid. It can be a gas too, because gases also flow. If it moves through anything that is a fluid, and there's a constant force propelling it in one direction. So, for example, a car has got, someone's got his foot on the accelerator and he's moving him. That's moving with a constant force forwards. Then, if it's moving through a fluid, so in that case, it would be moving through air. Then a resistive force, which you call drag, will start to build up, acting in the opposite direction. So so say for example, an object falling through air would experience air resistance, which is the example of drag in that case. If it's moving through air, we call it air resistance. That's an example. But obviously, if it's moving through water, you would call it water resistance. It's still drag. So drag is the general word to describe a resistive force in a fluid. Okay, that's due to motion. Now it's not the same as another word you might come across called upthrust. It's not upthrust. Okay, so let's maybe make a note that drag is not upthrust. Often confused with upthrust, because upthrust is also a force in a fluid. Briefly, an upthrust exists even if the object is staying perfectly still, but drag is only there if the object is moving. So what's drag due to? Drag force increases if the object is moving more quickly or if the object has a larger surface area. There is one more thing that can affect it. So we'll say or ... if the fluid is more viscous. In other words, it doesn't flow as easily. So if it doesn't, like honey or treacle or water compared with air, more viscous. So it's just how easily it flows. Okay. Opposite of viscous would be runny, I suppose. So how easily it flows. So the noun for how viscous something is viscosity. Yes. So if the fluid is more, anyway. So why do these three things have an effect on the drag in this way? Well, it's because if we think about what's actually causing this drag to occur, let's start off by drawing a cube, or let's draw a cube just here, and imagine this cube is moving through the air. Now the air particles are going to kind of be everywhere. So let's just draw a few air particles. Okay, so there are some extremely large air molecules or air particles. But just to make a point now, if this object was trying to move through these air particles, they're going to slam into the side of it, aren't they? The particle has to kind of move them out of the way, and as you move through as anything moves through air or liquid or anything really, any sort of fluid, the particles will hit it as it's going through it. Now you can imagine that if something's moving, let's have a look at these 3 points now. If something's moving more quickly, then they're going to be colliding with these particles more frequently and also with greater force. So they have to move more air particles out of the way and they're hitting them more quickly, and so they're going to feel a larger force for that reason. If it's a larger surface area, again, they're going to be hitting more particles more quickly. And if the fluid is more viscous, there's again more particles there, or the particles are harder to move out of the way. So again, there's going to be a larger force for those reasons. So the drag force, this resistive force, is all down to having to push these particles out of the way. When you get all the way down to it, you have essentially one of these air particles here, and maybe they're moving towards you like that, and the part of the the wall of this container or whatever it is moving that direction to the right. You have to then push this air particle so as it then goes backwards the other way like that. So that's the force that's needed to push that one air particle. And obviously, if you have to do that lots of times with lots of air particles, then there's going to be a bigger force. Does that all make sense? Right. So it makes sense then that if you're moving more quickly, then the air particles or the water particles or anything are going to be produce an overall larger force. And the same with if you have a larger surface area, or if it's more viscous. So that's air resistance or drag, water resistance, any of that. It's all the same. So that's the basics of that.